Good day. Today we're going through prime factors. The prime factors are just the factors of a number that also happen to be prime numbers. So first let's recap what a factor is. A factor is a number that can divide into another number without leaving a remainder. Let's look at 5 for example. The factors of 5 would be the numbers that can divide into 5 without leaving any remainders. So the first factor of 5 is 1. 5 can be divided by 1 5 times without any remainders. The second factor of 5 is 5. 5 can be divided by 5 1 time without leaving any remainders. So 5 has a total of 2 factors, 1 and 5. The two factors of 5 are 1 and 5. So a factor is a number that can divide into another number without leaving any remainder. So next, let's recap prime numbers. A prime number is a number that has only two factors. The two factors of a prime number are 1 and itself. 5 is a perfect example of a prime number since 5 has only two factors. The two factors of 5 are 1 and 5 itself. So anytime we have a number that has only two factors, which happen to be 1 and itself, this number is known as a prime number. Right, so the prime factors of a number are the factors of a number that are also prime numbers. So let's look at an example. Suppose we are asked to find the prime factors of 180. In order to find the prime factors of any number, we use a factor tree. In order to find the prime factors of 180 using a factor tree, we must first find a pair of factors that produce the number. To begin finding the prime factors of 108, we must first find a pair of factors that multiply to give us 180. So a pair of factors that multiply to give us 180 is 18 multiplied by 10. This is the first branch in our factor tree. Once a new branch is created, we check to see if we've found any prime factors. The third step of using a factor tree is that we check every branch for prime factors. At every branch of our factor tree, we must check to see if we found any prime numbers. So on this branch, we have 18 and 10. 18 and 10 are not prime numbers. So we must continue breaking down these numbers using the factor tree. So let's start with 18. So we repeat the second step. We need to find a pair of factors that produce the number. So a pair of factors that multiply to produce 18 is 9 by 2. 9 by 2 gives us 18. So now that we've created a new branch, we must check to see if we found any prime numbers. So 9 is not a prime number. However, 2 is a prime number. Once we find a prime number, that's the end of that branch. So this is the end of this branch here. So since 9 is not a prime number, we need to repeat step 2 and find a pair of factors that multiply to give us 9. So in this case, that could be 3 multiplied by 3. Now that we've created a new branch, we check to see if we found any prime numbers. So 3 is a prime number and we found 2 3s. So this is the end of this branch here. Now all we have left is 10. 10 is not a prime number, so we must continue breaking down 10. So a pair of factors that multiply to give us 10 is 5 multiplied by 2. So now that we've created a new branch, we check again to see if we found any prime numbers. 2 is a prime number, and so is 5. So we found the end of this branch as well. We have now successfully found all the prime factors of 180. The prime factors of 180 are 3, 3, 2, 5, 2. To double check our work, we can multiply the prime factors we've just found. When multiplied, they should give us back 180. So let's test it. So let's multiply our prime factors to verify. 3 multiplied by 3 gives us 9. 9 multiplied by 2 gives us 18. 18 multiplied by 5 gives us 90. 90 multiplied by 2 does in fact give us back 180. So the prime factors of 180 are 3 multiplied by 3 multiplied by 2 multiplied by 5 multiplied by 2. Next we have HCF and LCM. HCF stands for the highest common factor and LCM stands for the lowest common multiple. Prime factors can help us to find the HCF or the LCM of numbers. Let's say we are asked to find the LCM of 180 and 54. The LCM means the lowest common multiple. So the LCM of 180 and 54 is going to be the smallest number that's a multiple of 180 as well as 54. So the multiples, again, are just like the multiplication tables. The LCM represents the lowest common multiple. The LCM of 180 and 54 will be the smallest multiple that both these numbers have in common. There are 3 main methods to find the lowest common multiple. The first method is by listing the multiples of both numbers. This method takes the longest, as we would have to list the multiples of 180 and 54 until we find a multiple that they both have in common. Remember, the multiples are just the multiplication tables of a number. The second method to finding the LCM is called the box method. This method is covered in another video and it involves dividing the two numbers. The third method of finding the LCM is called the prime factors method. Let's have a look at how the prime factors method works. If we wanted to use the prime factors method to help us find the LCM for 180 and 54, the first step of using the prime factors method is we need to find the prime factors. Let's use a factor tree to help us find the prime factors of 54. To use a factor tree, we need a pair of factors that multiply to give us 54. A pair of factors that when multiplied give us 54 is 27 multiplied by 2. At every branch, we must check to see if we found any prime numbers. 27 is not a prime number, however, 2 is a prime number. So this marks the end of this branch. Since 27 is not a prime number, we must continue breaking it down. So a pair of factors that when multiplied give us 27 is 9 multiplied by 3. 9 multiplied by 3 give us 27. We must now check to see if we found any new prime numbers. So 3 is a prime number, so this marks the end of this branch. 9, however, is not a prime number since it has more than 2 factors. So we must continue breaking down 9. A pair of factors that when multiplied would give us 9, 3 by 3. So we must now check to see if we found any prime numbers, and 3 is a prime number. So this marks the end of this branch, as well as the end of our tree. We have fully broken down 54 into its prime factors. The prime factors of 54 in ascending order are 2, 3, 3, 3. These are the prime factors of 54. And to verify, when multiplied, this should give us back 54. So 2 multiplied by 3 gives us 6. 6 multiplied by 3 gives us 18. And 18 multiplied by 3 does in fact give us back 54. So we've correctly found the prime factors of 54. 2, 3, 3, 3. So let's write them in. Let's do 180 next. A pair of factors that multiply to give us 180, 90 by 2. So right away we found a prime factor, 2, and we must continue breaking down 90. 2 is a prime number, 90 is not, so we must continue breaking down 90. A pair of numbers that multiply to give us 90 are 45 multiplied by 2. 2 is a prime number, 45 is not, so we continue breaking down 45. A pair of numbers that multiply to give us 45, 9 by 5. 5 is a prime number, so this marks the end of this branch. 9 is not, so we must continue breaking down 9. A pair of factors that multiply to give us 9 are 3 by 3, and 3 is a prime number, so this marks the end of this branch as well as the end of our factor 3. So the prime factors of 180 in ascending order are 2, 2, 3, 3, 5. So let's fill that in. The second step to find the LCM of both numbers is we must find common factors and cancel one copy. So let's find the common factors between 180 and 54. Let's see what factors 180 and 54 have in common. 180 and 54 share a common factor of 2. They share a common factor of 3. And they share another common factor of 3. For each pairs of these common factors, we must cancel one side. So we can cancel one of these 2's, we'll cancel one of these 3's, and we'll cancel one of these 3's. The final step to finding the LCM of both numbers is to multiply all remaining factors. To find the LCM of 180 and 54, we must lastly multiply all remaining factors. The remaining factors are 2, 2, 3, 3, 5, 3. The last step to finding the LCM of 180 and 54 is to multiply these remaining factors. 2 multiplied by 2, multiplied by 3, multiplied by 3, multiplied by 5, multiplied by 3. When multiplied, this gives us an LCM of 540. The lowest common multiple of 180 and 54 is 540. The first step of using the prime factors approach to finding the LCM of numbers is to firstly find the prime factors of both numbers. The prime factors of 180 were 2, 2, 3, 3, 5. The prime factors of 54 were 2, 3, 3, 3. The second step of finding the LCM using the prime factors method is we need to find the common factors between both numbers. So let's look for the common factors between 180 and 54. These numbers have a factor of 2 in common, they have a factor of 3 in common, and another factor of 3 in common. For each of these duplicate factors, we cancel one copy. For each of these pairs of common factors, we must cancel one side because we only need one copy of the number. So let's cancel one side. We cancel one of these 2's, cancel one of these 3's, and we cancel one of these 3's. The final step to finding the LCM is to multiply all remaining factors. The remaining factors are 2, 5, 2, 3, 3, and 3. 2 multiplied by 2, multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 5 gives us an LCM of 540. Next, how can we find the HCF of 180 and 54? So the HCF stands for the highest common factor, and the HCF represents the largest factor that 180 and 54 have in common. There are also three methods of finding the HCF. The first method involves listing factors of both numbers until we find the largest factor that 180 and 54 have in common. This method takes the longest. The second method is called the box method, which is also covered in another video. This method is more efficient than the first method. The third method to finding the HCF is the prime factors method. Let's look at how we can find the HCF of 180 and 54 using the prime factors method. The first step remains the same. We must find the prime factors of both numbers. The prime factors of 180 were 2, 2, 3, 3, 5. The prime factors of 54 were 2, 3, 3, 3. The second step to finding the HCF using the prime factors method is to find the common factors. So this step is similar. We need to look for the factors that are common between 180 and 54. The factors that both numbers have in common are a factor of 2, they have a factor of 3 in common, and they have another factor of 3 in common. The final step to finding the HCF of both numbers is we want to multiply the common factors. The factors that 180 and 54 have in common are 2, 3, and 3. To find the HCF, we multiply these common factors. 2 multiplied by 3 multiplied by 3. 2 multiplied by 3 multiplied by 3 gives us an HCF of 80. Once again, the steps to finding the HCF using the prime factors approach were firstly to find the prime factors of both numbers. So these were the prime factors of 180. These were the prime factors of 54. The second step is we want to find the common factors between both numbers. So the factors that 180 and 54 had in common were 2, 3, and 3. The final step to finding the HCF is we want to multiply the common factors. So we multiplied 2 by 3 by 3, which gave us an HCF of 18. To practice these concepts, try finding the HCF and LCM of 12, 30, and 18. That's it, everyone. Thanks for watching. Take care.